Okay. Hello, everyone. Sound good? Sounds good. Okay, fantastic. So how many of you folks here love databases? Okay, and how many of you hate databases? Okay, and I guess the rest of you couldn't give a shit about databases, right? That's also fine. That's also fine. Well, anyway, let me start by a little bit away from a database topic, but talk about the open source as kind of its journey through usability. How many of you have been involved with open source more than 20 years? 20. Yeah. Okay. Well, and I remember being involved in what is like the late 90s, right? And the open source was kind of tricky, right? You would have to download the source somewhere, then maybe download some patches, so that works with your compiler, and then have to compile it. And kind of, it was kind of, you know, like installing every software felt like an achievement, you know, a day well spent, right? Anybody remembers that? No? Well, and I think if you look at that, since that time we had this like a never-ending journey through simplicity, making the open source software more simple to install and use, right? So you could see that journey through, you know, download, sources, patch, and compile to, you know, packages. When you had repositories, now we have also, you know, Docker, when you don't have to care about any, you know, dependencies or, you know, conflict on the paths or some other stuff, you know, just you can install the Docker containers, right? If you want multiple versions of the same software and same host, that's fine. They never will try to stay on each other toes, right? And with that, it of course becomes very interesting also to use technologies like Docker to run a database, right? So let's talk about that. Now, I think when we are talking about a database, it's important to recognize that two very, very different use cases, right? One of them is test and dev, right? The good thing in test and dev is the database are kind of pretty disposable, right? They're also typically relatively small. It's not performance critical, right? They can kind of provision database, you know, tear it down and so on and so forth, right? And Docker in this case is wonderful and was used, I think, in this environment for quite a lot of time, right? It even allows developer, let's say, hey, if I want to make sure my software works with, you know, Postgres or version X, Y, and Z, right? It's very easy to kind of spin it up all together, switch between them, and even in my kind of deployment environment. Docker also made it easy to develop their application stacks, right? If I want to deploy something more than a single component, I can use Docker Compose. Again, it's very easy. Now, if you look at Docker in production, there have been a few things here. First, if you look at some of early implementation of Docker, in certain cases there would be overhead, right? If you Google, especially if, you know, some old posts, you can say, oh my gosh, we have this kind of like a huge overhead. It runs much slower, right? Well, it's not really that much anymore, right? If you think about the isolation, well, wherever you're running a Docker, right, or let's say just using systemd, right, it's pretty much relies on the same kernel foundation of a C groups, right? There is not that much overhead out there if you configure that. The other one, what we found, is kind of like an extra complexity, just like, you know, a little bit. The thing with the Docker containers is by default, unless you configure them, they sort of contain the data as well. So you've killed your container, right? Boom, you lost all your data, right? Which some people find you know, surprising, right? And which is a big problem in production. That is very different compared to your kind of normal installation, where typically, even if you say, hey, you know, I want to uninstall the MySQL of version X and install the new MySQL of version Y, right? My data persists, right, in this case. Another issue what we saw, and I think that's also very much solved by now, is their monitoring observability, right? It was not supporting the Docker environment pretty well, right? And if you are using that, it was harder to understand what's going on compared to the conventionally deployed application. So if you look at where do the open source databases stand now when it comes to the Docker deployment, well, you see what the most open source database, some official Docker images. You'll actually often find kind of two, right? One is kind of maintained by Docker, and then there may be something maintained by certain company, right? In this case, it's quite commonly used for the test and dev, right? But raw Docker is not very commonly used in production, right? Saying, hey, we are, just deploying the database as Docker in production. I don't hear that that often. Right now, at Percona, we are also, you can think about that as a provider of open source software, right? And that is what we do with Docker, right? We do provide the Docker software for everything, all the open source software we have. Now, what is the big issue, you would say, with Docker, right? And that is what I would think is day two operations. Docker itself is wonderful, provisioning something, right? You can even go ahead and, provision in multiple databases through the Docker on different hosts, and then use something to, configure them in a replication or a cluster. That works fine, but it doesn't really help on its own to operate the database in day two, right? And what is a challenge in a database is that the database spends majority of its time in kind of a day two, right? When we already, provisioned it, and now we needed to kind of stay up and operate in many, actually, decades at a time, right? And there is a lot of applications when you expect your database is kind of never really to go down. So that is becomes a problem. What you also need in this kind of a high available and a day two is you often need a concept of a cluster. You need something to say, hey, I'm going to measure a database as a set of nodes, right? And manage that up, as a cluster, not as something which is provisioned on the single node, right? And Docker doesn't quite talk about this way. And that brings us to Kubernetes. How many of you guys use Kubernetes here? Okay, well, yeah, not a surprise, right? If you're such a 12 years. Wow, that is impressive. Yeah. Okay, yeah, yeah, that's fine. Yes, yeah, that's like you can always figure out, right, where like technical depth of recruiters at the company by how many years, right, of some new technologies they require. Okay. Now, if you look at Kubernetes and databases, I would say relationship here is kind of complicated. Why? Because Kubernetes was designed first for stateless application, right? It was kind of idea, hey, let us have this kind of wonderful solution for deploying stateless applications on Kubernetes, right? And then state is going to be kind of maintaining some database, right? Which is sort of somebody else's else's problem, right? And it actually took a while for Kubernetes to become good for stateful application over years, right? There has been a lot of work done, stateful set, and actually a lot of work is still ongoing, right? Kubernetes has a lot of work now going to with common storage interface, right, and all that kind of stuff, right, which is needed to really build applications, right, with IO-intensive applications efficiently. Now, I will have now like a pretty old quote, right, for Kelsey Hightower, right? He's one of a very well-known opinion leaders in Kubernetes space, right? And he was also, like at least 2 years ago, saying, "Hey guys, well, database in Kubernetes, I am not quite sure if that is a good idea, right? Or stateful workloads." But again, that was a while ago, right? But I think a problem here in this case, what a lot of those kind of initial observation, so they stay for many, many years, right? For me personally, for example, I was involved in MySQL from very early days. And you know what? MySQL used to not support transactions. And then probably, I don't know, what is it? Now more than 15 years ago, right? Probably more than 20 years ago by now, right? It started supporting transactions, and then probably another decade, I had people coming up, "Oh, but we cannot use MySQL because it doesn't support transactions." Like, oh my gosh. Very hard to change, right, people's opinion, right, once it was formed. But I think that is what's happening in the Kubernetes space in relation to stateful workloads, right? Anybody of you guys heard about Doc community? No? So this is a pretty cool organization which is specifically stands for data on Kubernetes, right? These are folks which are focused on running database and other stateful data-intensive applications on Kubernetes, right? And I wanted to show a couple of things from the surveys, right? What people from their survey, right, about what their folks are running. And you can see there are a lot of data workloads on Kubernetes with, with databases leading the way. Now, also what is interesting for me, right, and again, this is kind of, some of this data is about, 2 years old, but what is cool here is what we can see, what a lot of people are actually quite satisfied after we tried, so, right, because you can be doing something and saying, oh my gosh, that is a horrible, the worst idea ever, but now we've done it, we have to doing that. Well, you would ask here saying, well, of course, right, if you go to, let's say, Microsoft customers and ask, hey guys, how many of you are running Microsoft stuff? Well, a lot of you are going to tell what they do, right? That is kind of slightly biased, right? So we can also talk about CNCF surveys, right? In this case here, and this is like the 2002, right? Which is also unfortunately the last time we asked these questions, right? About the databases. Right, but what is interesting here is what you would see that there is a lot of growth among adoption areas, right? So I think what we could see the Kubernetes finally getting a lot of those features which are enough to get the databases running on it successfully. Cool. So another data point, maybe to convince you who haven't done already, is if you look at the database as a service solutions, many of them are actually running Kubernetes underneath, right? And I think that is especially common among, I would say, those like a new generation of a database as a service solutions, right? Because, well, if you've been starting working on your solution, let's say database as a service solution 10 years ago, well, you couldn't really use Kubernetes, right? I also have a friend which worked in both cases, right? One, he worked in some of a database company which built kind of Kubernetes, built sort of this database as a service solution without Kubernetes, sort of like on a bare VMs, and then another using Kubernetes, say, oh my gosh, it is so much easier, especially if you want now to add additional cloud providers and kind of and other stuff. It's really much easier than figuring all that stuff out directly. And what that means is, of course, well, because you are we're not constantly hearing about, oh my gosh, this kind of cloud provider running Kubernetes crashed and lost all the customer data, right, or something like that. Well, it seems to work, at least if you have an engineering skills to do that. Now, of course, you know what the promise of a Kubernetes is, but if not, or like to put it in my words, what is important for a database specifically. You can think about the Kubernetes as kind of a, doing for the data center for many servers, many resources, the same what Linux has done for operating system, right? And I think many of you can find a lot of imperfections in Kubernetes, right? And probably would be right, but well, as somebody who started working with Linux about 25 years ago, right? I can tell you, Linux started as a very, very bad operating system, right? I mean, then I was starting to work at that. It was, well, you know, 32 bits was kind of very common. You couldn't really allocate a lot of memory. Multiple CPU support was kind of a joke. And I'm not sure if somebody remembers that, but you couldn't even create a file more than 2 gigabytes in size, right? Which again, in a database world, that was kind of a very, you know, big problem, right? The database on that time would figure out, oh, how would we try to chunk our data so we would not store the same kind of table in a, you know, in a single file, because that's kind of will be a problem. Well, of course, things change, and a lot of those problems in Linux were, well, solved one way or another. At least to a point, right? We don't see a lot of Solaris running out there anymore. Anybody run Solaris here still? Still? Oh, okay. I see. I see. You should see his no. That was a very, very convincing no, right? Okay. Now, if you think about the open source databases on Kubernetes, in this case, I think it's kind of interesting because in many cases you would see the slower pickup by the vendors themselves. Because many vendors by that time, we can say, hey, we actually have a wonderful database as a service solution. And which is an opportunity for you to pay us a lot of money. So why would we instead give you a way to easily run the database on Kubernetes, right? That is kind of untold reality for many. But then, in this case, because there have been still kind of demand and there have been appearing the third-party Kubernetes solutions, well, then in-house solutions were developed, right? In Percona, we were really part of this as well. Oracle was not interested in building MySQL operator at all, but then at Percona, we built very good operators, and they say, well, you know what, people who want to run MySQL on Kubernetes, they just go to Percona. Not a good idea, so they kind of reluctantly build their own as well. If you look at how to run a database on Kubernetes, there are pretty much, you know, a couple of ways, right? Of course, you can deploy the container itself, right, on Kubernetes. You often can use a, you know, Helm chart to deploy that, right? Or also you can deploy their operator package. And I would recommend when you're looking at a database to always look for an operator, because their Helm tends to focus on that kind of, you know, day one situation. That is the operator which can solve all that kind of solution day two issues, right? Hey, you want a self-healing, you want, you know, scaling, you want kind of, you know, some backup functionality kind of built in, right? The mature operators, they can handle all of that, you know, life cycle for your databases, right? So at Percona, we at this point always have their operators as well, right, for technologies which we support, and they're kind of based on their distributions we have, right? So we have a sort of like Percona distributions for MySQL, MongoDB, Postgres, right, which you can also deploy on Kubernetes with their operators. Okay. Now, let's talk about the unsolved problems if you look at the Kubernetes. And I think this is kind of interesting, right? Because if you look at certain kind of people, right, I would call it like a Kubernetes natives, right? You think about the infrastructure as a code and all this jazz. They can say, well, you know what? We got operators. That is fantastic. We don't need your stinking UI, right? We got it from there. Go ahead and deploy and manage databases, right? But then there are maybe kind of not easy if you don't know Kubernetes. There is still a lot of people who prefer to deploy a database through ClickOps, right? You know, like go to, you know, RES, you know, and then click on a few buttons, right? And that is how you do a database, and that is, well, what Kubernetes on its own does not quite provide you yet, right? And here is we have, of course, the database as a service. Now, this is Germany, so the answer here can be a little bit different, right? So how many of you guys like do run the database as a service solutions? Okay, and how many of you just, you know, provision the databases yourself, right, even if you're using the cloud? Oh, okay. Well, so the situation is different here, right? I now live in America, mostly speak America, right? And one thing you probably know about Americans, no, two things you know about Americans. A, Americans are lazy. B, Americans like to waste money. So the answer, right, out there would be very different, right? A lot of people would say, hey, no, we just, you know, prefer to go and pay for, you know, Amazon RDS, right, or whatever solution. So we see a lot of database as a service deployed, right, in those kind of scalers, right? And that is, I think, which is very interesting, right? We can see the proprietary clouds, they bring a great usability, of course, right? That is a very easy to get that databases out there, but it also comes at a great cost. And in this case, I do not only mean the cost as in terms of dollars, but also the other stuff, right? You have, you know, lock-in. You have also that's kind of a long-term risk running from wherever they want to do in terms of pricing changes, right? Or wherever they still even kind of want to, you know, serve you down the road. So if you look at those state of the clouds, what do we really have? If you say, hey, I just want to have a RDS-like experience to provision my databases. Well, here's what we have. We have, obviously, all the major clouds have a proprietary database as a service offerings. And now it actually kind of extended to also like second-tier clouds. If you go to, like, you know, Linode, DigitalOcean, right? A lot of them say, hey, we also have like something maybe kind of simplified, maybe not as features powerful, but some sort of database as a service solution. Now, if you look at the database vendors themselves, they also have typically their own branded whatever cloud services. You know, think about like a Confluent Cloud, MongoDB Atlas, Cockroach Cloud, and so on and so forth, right? Probably for any database technology, you can get like, oh, we have a XYZ cloud, right? And then there are also some people like Avian, you know, Instacluster, which can say, hey, well, we'll provide that sort of like our proprietary management level, right? But we are going to give you a variety of open source solutions available on variety of clouds. Now, what is missing here? Anyone? The open source, right, is missing here, right? Unfortunately, we can see is what some open source solutions to say, hey guys, we are just going to do that, right? So that is a problem. Now, what is also I think is interesting in this case, what you would see number of companies have been even changing their license to kind of prevent things like that to be created, right? And to make sure the only database as a service solution is the proprietary, right? Well, MongoDB is obviously like Elastic, change a license 2 years ago, right? More recently, the, you know, Redis have moved also kind of cloud, non-competitive, non-open source license, right? So there is kind of, well, to a certain extent, there is and move to opposite direction by number of cloud vendors to say, hey, not only we are not, of course, going to build the open source solutions because cloud is how we monetize that stuff, but we want to prevent other people being able to do that. But so what is the point with a cloud, right? Why would you either kind of bother, just can't you, roll out your software yourself? And the thing here is what the database as a service, that really removes a lot of kind of, toil, various kind of things you have to do just to get the database running. And that allows developers often to focus, well, what they kind of pay to do, right, to build their to build the application, right? And I think what is also interesting in this case is it does require completely different level of skill. The skill is required versus just saying, hey, I'm wrote an application which can use the database, and then to deploy and operate that database in a non-cloud way is very much different. What you'd also see with a lot of database vendors is they like to use open source as a part of their marketing, right? Have you heard anybody use the terms like, oh, this solution is open source compatible, right? Or open source based, right? Like think about guys like Amazon Aurora, for example. Well, and what I like to call that is like a Hotel California based comparability. Right. Well, I'm not sure, right, if anybody here gets the joke, right? But this, there's a very famous song, right, Hotel California, when it says, well, you know what? It's easy to check in, but it's very hard to check out, right? And that is typically how the open source comparability is built, right? We are at Amazon Aurora want that to be very easy for you to move from MySQL to Postgres. Right, it's going to wonderful, right, and then they're going to tell you what it has, some wonderful additional features. You start to use them directly, or maybe indirectly, right, because of some performance properties and so on and so forth, right? And hey, guess what? Moving back to the open source becomes very, very problematic, right? And I think this is a very deliberate, right, and already proven business tactic, if you like, right? I think it's interesting to see is, well, how many of you guys see a lot of a new application built using Oracle, for example? Well, I don't see a lot, but I still see a lot of applications using Oracle because once you build something, right, on Oracle, well, it's very hard to re-architect and move your data to something else. Right, that is kind of, some companies who have done it. It's for a large company, maybe multi-year, multi-million-dollar project, right? And that is, in general, for example, why databases often have a very good, pricing power, right? Good kind of valuation compared to their revenue, because their customers tend to be very, very sticky, right? Once you got your data somewhere, it will be very hard for you to move it somewhere else. Now, another thing which comes with databases, well, of course, is this kind of like a fully managed solution, right? Well, which is kind of very interesting, right? Because you talk to cloud vendors and say, hey, guys, do I need anybody to understand the databases? Well, okay, you kind of don't, right? Because it's fully managed, right? And then you say, oh, but who's going to be responsible for database security? Oh, it's a shared responsibility. What about performance? Oh, it's shared responsibility too. Right, so is it kind of fully managed or is it shared responsibility? Can you please pick something? Well, yes, we pick both. Our sales team and marketing pick kind of shared responsibility because, well, not pick the fully managed because that is what allows us to sell, and then in the contract we'll define that as a shared responsibility because that means we're not actually responsible for anything, right? If your database is hacked, well, it's not our problem, it's yours because that was shared responsibility. The database as a service also, of course, creates the vendor lock-in, right? And I think even if you talk about that not being painful now, it is likely to become even more painful in the future, right? Because as it kind of takes a time to create that lock-in situation, right, in this case, and create that pricing power, right? We can already see that, let's say, in AWS. If you guys want to see, for example, how much a premium AWS RDS was charging, you know, several years ago, right, compared to the infrastructure cost versus now, you will see that has been significantly increased, right? It was, I think, starting from like a 40% premiums when the product was started to, you know, 70%, right? I think even kind of 100% for new generation ARM instances. And actually, we have a history lesson here, right? Anybody of you recognizes this young, good-looking guy? No? Anyone? Yes, well, this is the Larry Ellison himself, right? And RSI is actually how the Oracle was called first, right? And what was Oracle doing when it was started? Well, actually, Oracle was saving you from a hardware vendor lock-in, right, in this case, by the IBM. Because, well, before that time, right, you really need to store lots of data. There is an IBM mainframe, right, and so on and so forth, while like Oracle could run on a smaller systems like Suns. Well, how things change? Right? Now, how many of you would say what the Oracle is somewhere which is saving people from vendor lock-in? Anyone? Well, what about Oracle doesn't have customers, Oracle has hostages? How about that? Well, that is something what I often get a lot of people to agree with, you know. Even Oracle salespeople, they can say, yeah, you know, that's how we get our fat commission checks, right? I mean, so with that, going back kind of to the cloud from this little bit of historical diversion, I wanted to show this picture. And this picture is, I don't know, like maybe 15 years ago, we can even see like a very old log of Amazon Web Services here, which is when we talk about the cloud computing. Saying, hey guys, the cloud computing is like electricity, right? It doesn't make sense for most of us, most of the time, to create our own electricity, right? And I think that is a good analogy of what the cloud should be, right? But that has changed, right? I don't think they're using that slide anymore, because now we have to say, well, but you know what? Now, if you are going to buy the fridge or microwave, right, whatever, or TV from Amazon, right, if you ever want to switch your electricity provider, you can't use this stuff anymore, right? That is what it doesn't make sense, right? If you are talking about commodity, it's got to be kind of standardized, right, in this case. And that is where we can come to Kubernetes again, because the Amazon API is not commodity, it's not electricity, right? It's kind of like this very proprietary Apple plug, which I think was, you know, outlawed in Europe, right? Their Kubernetes is your unified commodity interface, right? And that is where it brings us to the choice about how we can use the cloud. And again, you can replace AWS with your, you know, favorite other proprietary, you know, highly, you know, differentiated cloud, right? I think that is where we can look at the solutions coming from a cloud computing foundation, which allows us all that thing which comes with freedom. And what I think is interesting is what you can see is there is like a lot of stuff which has been created in the last years, right? And yes, often it's kind of not as polished, not as well integrated, right, as in, you know, for AWS. But you know what? It's take times, right? We already spoke what a while back, you know, Linux was not that polished, polished either. So going back to the database as a service question and what we would like to see. Well, I think what is wonderful about Kubernetes, it's available everywhere, right? It's available on the same kind of clouds. You can roll it out in a data center on-prem. You can run it on the edge. You can run it on your kind of laptop, right? Or, anywhere, right? And then we can use that as a foundation to build a RDS-like solution. Right. From our standpoint, we look at having the operators, right, in Kubernetes as a foundation, right, because I think it's good to kind of build technology in layers, right, without trying to reinvent the stack everywhere. And then we are building another project, right, which is called Percona Everest, right, which is kind of currently in beta, but that is also like a fully open source software, which allows you to deploy their software, right? They deploy the databases, kind of back them up, right, wherever, right, with RDS-like interface on any Kubernetes backend anywhere. So to sum things up, right? I think it's interesting to see that kind of a curve of maturity for open source databases, right? You can say, hey, well, if you look at the databases, it's kind of on Kubernetes, it's sort of like a solved problems. In the Kubernetes, we kind of get in there. We are in a relatively early stages of that really providing database as a service experience. And look, while they're building the software, I do not expect to actually want to Percona to be sort of like the only solution in this space. I actually expect there will be other solutions popping up in this space, right? Like I think we already have tools like Rancher, for example, which allows pretty cool way to deploy various stuff, right? I think we just did not yet care about like having sort of like a specific extensible UI, right, and stuff, and API to be able to, do everything full life cycle what databases require. So yeah. I also wanted to highlight what the database service. I think it won a lot of heart and mind, right? Even if it's not kind of completely, I think we are all moving towards getting things as simple as possible, right? And maybe the database as a service is just that stepping stone before AI overlords will take over, right? But for now, that is a state-of-art simplicity, right? And I think that is what you will see developers continue to gravitate to. Vendor lock-in sucks, right? Well, at least that is what we in open source space very much believe it, and the open source is, I think, as in many other cases, is going to come to the rescue, at least kind of giving us an options, right? Because I think the options is wonderful, because even if you don't use that kind of like open source solutions, but use some proprietary stuff, right? The less leverage the vendors have, the less they will have a, to go to take advantage of you. With that, I also have not one, but two public announcements. One is, if you guys like this all the kind of database stuff, we also have our own little free event here at Percona tomorrow called Percona University, right? So if somebody is especially local here, welcome to attend. And if you guys say, hey, you know what, I already have to work tomorrow, especially after, couple of busy days, we also have another event in the evening where we are going to take a group of people to do some stand-up paddleboarding. I mean, I'm somebody who just, likes, I think the best type of networking you can do, right, is not stuffing yourself with food or beer, but, going somewhere and doing some adventures together. I know many of you will disagree, but that's just me. That's just how I roll. Well, anyway, there's still a couple of spots left, so if somebody wants to join, let me know. And if that's all I had, and I think I have like about 5 more minutes, right? So I would be happy to take some questions.
Thank you very, very much. Great talk. So, are there any questions from the audience? In the back.
When we run our databases in a Kubernetes cluster, do you see any limitations you have to look for so that it's performing good or the user experience is the same like running it native?
Yes, the question was about performance and user experience, right? Oh, actually I have a microphone, so I don't need to repeat the questions. Okay. Well, I mean, there are certain things, right? Like one thing I would say, you can look up, I have a presentation of best practices around database on Kubernetes, right? You can find some, ideas out there, but generally, yes, right? I think what is interesting in this case is often the Kubernetes environment when it gets provisioned, right? The host type it uses and whatever, it's maybe optimized for stateless applications, and you often need to optimize it for stateful applications, right, as the databases are. One specific thing what we see a lot of questions is, well, making sure the storage is optimized, right? If you use like a local storage, right, if NVMe and such, it can be very fast, right, even on Kubernetes. If you use for a block storage, right, make sure that's appropriate for a database workload, right, which can be different from your stateless application, right? And then also there's like a good advice, like don't do stupid shit, right? Like for example, when you deploy in database clusters, you need to set up anti-affinity rules, so you don't have like a 3 nodes database cluster where actually all the pods happen to run on the same physical node somewhere, right? And if it crashes, it takes everything together, right? So things like that.
Thank you.
All right. More questions?
Oh, yeah. What do you think about projects like Pixd, which claim to be a battery included Postgres distro as a free RDS alternative?
Which one?
Pixd. You don't know it?
Well, I think I'm not sure. Well, I think there are. I've seen a number of folks, right, doing that stuff, this stuff like that. And I think that's wonderful, right? What that's coming together.
Okay, thank you.
I mean, I think if you look at that, there is a lot of takes, takes on that. Right? If you're interested in Postgres, I think there's this interesting open source project called Neon, right? I think they do like a pretty cool thing of kind of separation of storage and compute for Postgres. And now what I like is, well, there's like a bunch of different like operators for Postgres. Oh my gosh, I can't believe I just forgot the project name. Anyway, you weren't asking me about that. Oh, well, there is a cloud native PG, right? There is a stackgrass, right? The interesting thing with stackgrass is because we also have some UI built in, right? Kind of doing like similar to what we are doing, right? But from a little bit different angle.
All right. If there are not any more questions, then thank you again for the great talk. And yeah, applause.